Hi! This instructional video is about circles, and this time, square that circumscribes a circle, or the circle that is inscribed in a square. And the radius of that circle is 3 units. So here's a circle, and the radius is 3 units, and the square. Oh, that's touching, okay? Just say it's touching. Alright, here we go. So here's a square. Of course, a square, all sides are congruent. So what they're asking is, what is the total area enclosed within the square, but that is outside the circle? So we're talking about that shaded region over here. See if you can figure this one out. Go ahead. Alright, so to find, first we should find the area of a square. And from that, we subtract the area of a circle. And what will remain is the corner pieces. So the area of a square is found by A is equal to length times width. Or you could also say, because the square has all congruent sides, just simply one side square. And then from there, we're going to subtract the area of a circle, given a radius. And the equation, or for the formula for that, is pi r squared. So A is equal to length times width, or side squared. And where will we get that side? Well, I strategically drew my radius horizontally parallel to the side of the square, so that we could see that the full length, or the diameter, is double the radius. And the diameter is the same as the distance, or the width of that square, which is 6. And square by definition, all sides are congruent, then this is also 6. So the length times width, or the side squared, is simply 6 squared. So the area is 36 square units. That's nice. Now we just have to find the area of a circle and start to subtract that away from the square, which will give us the remaining pieces. So the area is pi r squared. So pi and the radius was given as 3. So therefore it's going to be 9 pi. 3.1415, something like that. So let's go ahead and use a calculator, because I want to use all the decimal numbers. 9 times pi, which is 3.14159 something, is equal to, what's that, 28.27. And we're going to take that away from the square, which is 36 units squared. And the difference is going to be 7.7, let's round it up to 2 decimal places, 3. That's a unit squared, by the way, right? So this is a unit squared as a final answer. So this was an easy one. Well, if that's easy, why don't we try this one? A circle with a radius of 3 units circumscribes a square again. So let me illustrate that for you also. Here's a circle and has a 3 units, that's a radius. And it circumscribes a square. You know what? Let me use that as one of the vertices as a square to help us visualize this. What percentage of the area of the circle is enclosed by a square? See if you can figure that one out. Alright, so this one's a little different. When a square circumscribes a circle, that wasn't too bad. But when a circle circumscribes a square, we have a different situation. So to find a percent, we had to find the area of a circle. And then we also have to find the area of the square. And we have to find the ratio of the two to find the percentage of the area of the circle. So let's first find the area of a square. Area of a square. So let's take this one out. Here's what we have. And it says the radius that circumscribes a square, that was a 3. But now, if I look at that as a square, where the radius is going to be the same as the line that goes from I guess this would also be 2 lines diagonals that intersect, is 3, then the full length is going to be another 3, so it's going to be a 6. So now, if you take half diagonally a square, that's going to become an isosceles with the hypotenuse of a 6. Now, if you use the Pythagorean theorem, a squared plus b squared equals a c squared, or you could also use the ratio of an isosceles triangle, where we say if this is x, then this is square root of 2x. We'll do it both ways. So for Pythagorean theorem, since these two sides are congruent, what we're going to be doing is we're going to square it and we're going to double it. So we're going to just call this 2x squared. It's like saying take square of a side, but we're going to double it because these two sides are congruent. And we're going to let that equal to 6 squared. So that's going to be 2x squared is equal to 36. Solve for x by dividing out the coefficient 2. So x squared equals 18. And when I square root both sides, x is equal to square root of 18. Let's see, 18 is made up of 9 and 2. So the square root of 9 is going to be 3. So 3 comes out, and inside the radical is going to be a 2. So that each side is 3 square root of 2, 3 square root of 2. Now, if you were to use the ratio of an isosceles triangle, a right triangle that is, you're gonna say square root of 2x is given as 6. So you're going to solve for x by dividing the coefficient, which is a radical, square root of 2. So x equals 6 square root of 2, but you have to rationalize this quotient by multiplying the top and the bottom of that by the denominator square root of 2. So x equals, 6 square root of 2, but when you multiply two identical radicals, the radicand comes out, and the 2 reduces 6 3 times, so therefore 3 square root of 2. Either way, you get the same side. There it is. So what? Well, that, since it's an isosceles with the two congruent sides, if we put that back to a square now, this is a square 2, 3 square root of 2. The area of that square is now length times width, so 3 square root of 2 squared. 3 times 3 is 9. Radical 2 squared is going to be just 2, so that's going to be 18. Alright, so that's the area of the square. Now the area of a circle is pi r squared. So that's pi times radius was already given as a 3. And the radius is 3, so that's 3 squared. Therefore, it's going to be 9 pi. There it is. So we found the area of a square, and we found the area of a circle. So it's like asking this. If you had this whole pizza, and if you ate only this portion, what percent did you eat of the whole thing? So the whole thing always goes on the bottom of a quotient when we talk about percentages. So that's 9 pi. And the part that we ate is 18 units squared. So that simplifies to become, well, that goes into 18 2 times. So it's 2 over pi. And so all we have to do is take our calculator and we go 2 divided by pi equals, it's going to be approximately 0.6366. And since they're asking for a percentage, we're going to just round it up to approximately 63.7%. There it is. Now here's a challenge for you. Is that ratio going to be the same every time we put a square or any kind of a quadrilateral given a circle with a radius? Would that ratio always be the same? Maybe I should do a follow-up instructional video on that one, huh? Alright, so try it. Good luck.